This is Dr. Theodolite Reddy, Professor of Civil Engineering, Lord's Institute of Engineering and Technology, Hyderabad. Today, for the discussion, we are taking the instrument Theodolite. In that, we should be discussed about component parts of the theodolite, types of theodolite, temporary adjustments of the theodolite, and also different observations to record the data in the field. Now come to the first one, component parts of the theodolite. In that, this component is known as the base plate of the theodolite. These three are known as the foot screws, which meant for level the instrument. This part is known as the tri-batch or trivet. This component is known as the lower plate. This component is known as the upper plate. These two scales are known as the vernier A scale and vernier B scale. Both are lying exactly opposite to each other. So, the angle difference between the two scales A and B is 180 degrees, 0 minutes, 0 seconds. It was on the upper plate of the theodolite. Lower plate consists of the two important screws, that is lower clamp screw and the lower tangent screw, whereas upper plate consists of two screws, upper clamp screw and upper tangent screw. Now this component is known as the A frame or index frame. This is known as the vertical circle of the theodolite. Again, vertical circle consists of two scales, vernier C scale and vernier D scale. Vernier A scale and vernier B scale are meant for measuring the horizontal angles, whereas vernier C scale and vernier D scale are meant for the measuring the vertical angles. This is known as a longitudinal bubble. This part is known as the telescope of the theodolite. This end is the object vane and this end is known as the eye vane. Now here, these are the component parts. Next we should be discuss about types of theodolite. So theodolites are two types. In that, first one is transit theodolite, second one is the non-transit theodolite. Now we should see the difference between the transit theodolite and the non-transit theodolite. If the telescope has a provision to turn 180 degrees about the horizontal axis in a vertical plane is known as the transit theodolite. If the telescope has no provision to turn about 180 degrees about the horizontal axis in a vertical plane is known as the non-transit theodolite. Now come to, at each setup of instrument, we should do the temporary adjustments. If we take the temporary adjustments, there were three operations: setting up, leveling up and elimination of parallax. Setting up, first we should take the instrument from the box and keep on the head of the tripod stand and see that the instrument was exactly over the station mark. Once the instrument was seated on the tripod stand, next observation is, see that all the threads above the foot screw should be same number. Suppose if this screw has a 3 threads above it, and see that remaining 2 foot screws have the same number of threads, 3 on the upper side. Next, leveling the instrument. So here, first keep that, here we have 3 foot screws are there. First, keep the telescope parallel to any 2 foot screws. 1, 2. Now we are keeping the telescope parallel to 2 foot screws. Operate the 2 foot screws either in the inward direction or in the outward direction until the bubble is at the center. Next, turn the telescope that the object vane should lie on the 3rd foot screw, or telescope should make an angle 90 degrees with the line joining of the 2 foot screws. So this is the line joining of the 2 foot screws. So this will be the telescope. Next, operate the 3rd foot screw either in the clockwise direction or in the anti-clockwise direction until the bubble is at the center. Again, bring the telescope to the previous position. Again, simultaneously turn the 2 foot screws either in the inward direction or in the outward direction until the bubble is at the center. Now again repeat the process that the object vane should fall on the 3rd foot screw. Operate the 3rd foot screw clockwise or anti-clockwise until the bubble is at the center. Now we should do the 3 or 4 trials. After the 4 trials, if you turn the telescope in any direction, the bubble is at the center, then we can be say that the instrument was leveled. In temporary adjustments, the 3rd operation what we should be doing is elimination of parallax. Take a piece, how we can be identify that the instrument is suffering with the parallax error. We know to note the reading from the telescope, inside there was a horizontal and vertical crosshairs. Horizontal and vertical crosshairs. At the time to start the reading, to take the reading in the field, the crosshairs will not be visible. Once the crosshairs inside the telescope not visible, we can be understand that telescope is suffering with the parallax error. Take a piece of white paper, keep in front of the telescope. Operate the eyepiece either in the clockwise direction or in the anti-clockwise direction until there is a clear visibility of the crosshairs inside the telescope. Once the crosshairs are clearly visible, then we can be understand that telescope is free from the parallax error. Then we can be go for noting the reading in the field. So here second item was completed. Now come to different observations what we can be use in the field to note the readings in the field book or to record the readings in the field book. First one, face left observation. So here face left observation. If the vertical circle, you know this is the vertical circle. If the vertical circle is at the left of the observer while taking the reading is known as the face left observation. Here the person who is noting the reading or maybe taking the reading is known as the observer. Face right observation. Face right observation means if the vertical circle is at the right side of the observer while taking the readings is known as the face right observation. Face right left swing. If the vertical circle is at the right of the observer, because here I am the observer, I am noting the reading, and direction of the rotation of the telescope is towards left side is known as the face right left swing. Suppose face right right swing. If the vertical circle is at the right side of the observer and the direction of rotation of the telescope is towards the right side is known as the face right right swing. And the last two observations what we can be note here is face left left swing. Already you know it. Face left means the vertical circle is at the left of the observer while taking the reading. Face left left swing. If the vertical circle is at the left of the observer and direction of rotation of the telescope is towards left side is known as the face left left swing. Last one, face left right swing. If the vertical circle is at the left of the observer and direction of the rotation of the telescope is towards right side is known as the face left right swing. Thank you. Next we can be continue the methodology what we can be using the theodolite, we can be evaluate height of the object and also distance from base of the object to the instrumentation using the two methods. In that, number one is the single plane method or same plane method. Second one is the double plane method or different plane method. So when we can be apply the single method, when we can be apply the double plane method, we can be discussed now.